Hey, in this lab we are looking once again at kinetic friction, and just like the first kinetic friction lab we did, we'll be looking for the coefficient of kinetic friction, mu k. Except this time we have a setup where our wooden block is going to be dragged up an incline at an angle at a constant speed. We have some of the same stuff that we had before. For instance, we're going to be using a wooden block once again with the string attached to it, and the other end of the string there will be a loop. It will be attached to our force sensor, which I'll use to pull the block at a constant speed up the incline. We have our little tablet right here connected to our force sensor once again, and that hook on the force sensor will be measuring the pulling force, and since I'll be pulling the block at a constant speed, this force should be balancing with all the forces in the opposite direction acting on the block. We'll see a demonstration in a moment. To demonstrate the setup, I've got the block over there sitting at rest on the inclined plane. I also have a weight hanging over there just to prevent it from sliding at the moment, but we won't have a weight hanging on there when we take our measurements. It's very important that we note the incline angle of the plane. That's indicated by where this pointy part of that metal thing is pointing on our protractor. So that angle is in degrees. I've placed a spirit level on top of the incline just to double check the angle. Looks good. That angle that we have here, that we also saw on the spirit level, is the same as the angle right here and tells us how much the incline is inclined in degrees. I'm going to place some clamps at the end of the table where the incline meets the table, just to make sure nothing is moving while I pull on the block and collect my data. I've also made a tiny loop in the string up here at the top so I don't need to be pulling down at the bottom where the paper clip is. Just like in our last experiment with friction, we're going to be adding weight on top of the block. Last time we had the block coming across the surface of the table. We took a measurement for the amount of force we were pulling with, and in that case the force we pulled with was equivalent to the frictional force pointing in the other direction. And then we put more weight on top and did the experiment again, added more weight, did it again, and used that to determine mu k, the coefficient of kinetic friction. We'll still be looking for mu k, but this time, when the block is on the incline and I'm pulling it at a constant speed up the incline, the tension force in the string attached to the block is not going to be equivalent to the force of kinetic friction in the opposite direction. However, we do know that since it's moving at a constant speed, the acceleration is zero. Therefore, all the forces must balance out. So we're going to have to do a free body diagram to see exactly what forces are acting and in what direction. And then we can see what needs to balance out with the tension force. Friction will be in there somewhere. Since I want to do multiple trials, or rather different trials with the different amounts of weight on my block, I need something to put the weights into. Otherwise, as the block is traveling up the incline, my weights will probably just fall off. I've decided to take this little plastic drawer thing and just attach it to our block, kind of like this, so that we can place the weights inside for each of our new trials with more weight in there. And then that way the weights won't fall off. I think that'll hold. I've decided we'll do a trial with just the block and our little sled bucket thing attached to it first by itself. And then each time I'll probably add a couple of these weights here. Each one of these circular weights has this mass. Focus. Please focus. Each one of the circular weights this size has this amount of mass. So I'll tell you how many I'm adding each time. We'll probably do 2 at a time. I don't know. We'll see what happens. First, we're going to need to measure the mass of our little sled dude here. I've zeroed my triple beam balance. So now we're ready to take a mass measurement. That's nice and balanced. Here's a close-up so you can see where each particular mass is on the triple beam balance. We're almost ready to do our first run, but I gotta remember to zero the force sensor. In this trial, we have just our wooden block and our empty sled on top. The wooden block is the only thing in contact with the wooden incline. We should have the mass of that from our triple beam balance. Well, that's pretty difficult to do. We have a clear peak at the top right here when I first started moving the sled, and then I kind of stopped it accidentally once again over there. So our kinetic friction is going to be somewhere in here for our constant speed moving up the incline. So let's analyze that. Again, this is just the sled by itself with our, by sled I mean the wooden block and the plastic thing on top. Now we're going to add two of these golden colored weights that I showed you earlier to the sled. So now the total mass is the mass of the wooden block sled that we measured on the triple beam balance plus two of those little weights. Okay, this one looks usable. I have a clear peak at the very beginning there, right up at the top where we broke static friction, and it looks like we dropped down and we got something somewhere around here that we can use for kinetic. It looks like I kind of stopped it again. As you can see, there's another peak later on. Okay, so now we have some data about our second run, which was the sled plus two of those golden little circle weights. To try to get our data to come out a little cleaner, I'm actually going to add now 4 more of these guys, which means we'll have 6 total. There's another 4 of the same type, so we'll have 6 total of these in our sled. And hopefully if it's heavier, it's easier for me to get better data. The same was true of dragging the block across the table horizontally. It's a lot harder to get good data if it's a really light object you're dragging. Okay, that one's probably the best for that trial. So this one has our little sled plus we have 1, 2, 3, 4, 5, 6 of those golden weights. And while I was watching, I was dragging it throughout this portion, and then I eventually stopped and I was kind of balancing it. So we're going to use this selection here right after our first peak, statistics force. And there we have that. All right, our next trial, we're going to add in this block, and this is its mass in grams. So we're just going to throw a bunch more in there. I still have all of the 1, 2, 3, 4, 5, 6. That's 6 of these circle weights, and now I'm adding in this whole block as well. I think this is run number 4. I've already lost count. So here we go. Let's see what we can get. Oh, that looks much better with much more weight in there. Like the way that looks. So that one's probably one of the better looking ones we've done. Added much more weight and now it's looking good. So we're going to analyze before it gets kind of crazy. On the right side over here is when I start to, it's harder for me to continue to pull down without hitting the table. So I think right here really is probably the best place for me to do my analysis. So you kind of gotta, it's not as simple as saying highlight everything after the peak. You need to use your judgment. Okay, so there we have a mean value for the force of tension. That's what we're measuring here. Don't remember, it's not like last time where we're saying the tension force is the same as the kinetic friction, because there's a portion of gravity that's also pulling down the incline. Okay, so this is equivalent to the force of tension that's being directly measured by the force sensor. Let's see if we can get a couple more runs in before I get kicked out of my room. Found another block. Let's throw this on top of it. So everything's increasing. I haven't taken anything out of the sled. So we got our, I think it was 6 of those golden circle weights. And then this guy from last time, that's still in there. Come on, focus. That one's still in there. And then we're adding this one, which is a slightly different amount. Now that's in there. And we'll see if we can do one more after this. Okay. Well, that's kind of getting heavy. All right, also not too bad on that one. You can see how the force increases. After it breaks, it's pretty steady, and then it starts to increase again. That's either part of the imperfections on the wooden incline, or it's just really much more difficult to pull it at a constant speed. All right, we're going to throw this in on top now. So that's a bunch more we're adding. Just to prove to you, we still got all this stuff is now in there. Probably try to stack this a little better. That. All right, now it's all in here. Here's the last trial. So, okay, and there we go. That looks like enough trials. All right, so there's our last trial I had to redo. I saw some anomalous stuff going on, but this is again with our full sled of all 6 golden circle weights plus these 2 blocks here plus this final block. So I did a retrial of that, and we have a better value up there on the screen now. So let's do now the second to last trial, which was I'm going to take out this one, and I believe we just had the 6 round golden weights and then these 2 block masses here. So we're going to redo that one because it didn't look too hot either. All right, let's see what we get here. All right, that looks like a really good graph, actually. That's plenty to analyze. Let's see what we got. This is again for the what we were calling run number 5. So this is the second to last run I did again. Okay, those retrials for runs 5 and 6. I just did them backwards. I did the run for trial 6 and then the rerun for trial 5. That one you see on the screen now is with the 6 golden weights and then these 2 guys. And that should give us a better overall data where we can see a good trend. We should make a graph again, but super important thing to remember about this lab is that the tension force now, because we're on an incline, the tension force is not the same as the frictional force. That's the way it was before on the horizontal tabletop. Because when we're pulling up on our tension force this way, friction is indeed in the opposite direction. But like we're dealing with on our inclined plane, gravity's straight down, but a portion of gravity is also pointing down the incline. That means that our tension force, assuming we're pulling at a constant speed like we should be, the tension force going up the incline is going to be balancing with the kinetic friction plus that component of gravity that also points down the incline. And that's why we got to do our force of gravity and then make this right-angled triangle so that we can see which components of gravity are going down the incline and which component of gravity is going perpendicular to the plane and balancing with the normal force.